Okay, this is our second revision video for paper 1, and we are focusing now on equations with roots. So we are going to solve for x in the following 4 examples. In our first example, we have the square root of x minus 2 on the left and 4 minus x on the right. Now in order to solve x, we need to get rid of the root first, so we square both sides. Now, if you square a square root, it will remove the root and you only have the contents left. So it's x minus 2. And on the right hand side, if you square 4 minus x, you will have 4 terms. So it is 16 minus 4x minus 4x plus x squared. A common mistake is to say it is 16 plus x squared. But remember, when we square a bracket, it becomes 2 brackets, 4 minus x times 4 minus x, and we multiply each term in the first bracket with each term in the second bracket, and that's why we have 4 terms. Now what you can do is you can add up like terms to simplify, and in order to solve x, you can transpose the x and minus 2 over to the right hand side. So then you'll have x squared minus 8x minus x plus 16 plus 2. So the minus x comes from transposing the x, and the plus 2 comes from transposing the negative 2. And now if I simplify further, I have x squared minus 9x plus 18. Now you can factorize that trinomial in order to solve x. So remember to check your factorization. So negative 3 times x is negative 3x, and negative 6 times x is negative 6x, and together that becomes negative 9x, which is the middle term. Now I can solve x. So x minus 3 equal to 0, or I could say x minus 6 equal to 0. So therefore x is equal to 3, or x is equal to plus 6. But what you need to do is check whether or not these values are true, and we only need to check when we have these square root solutions. So if I substitute 3 in the place of x, it's 3 minus 2. So I substitute 3 in our original sum, and I want to see if that is equals to 4 minus 3. This is then square root 1 equals to 1. Therefore, it's 1 equals to 1. So it means that x can be equal to 3. And then I check the 6 as well. So it is 6 minus 2. And I want to see whether or not it's equals to 4 minus 6. Now on the right hand side, I have negative 2. And on the left hand side, I have the square root of 4, which is 2. So 2 is not equal to negative 2. Therefore, x cannot be equal to 6. So remember to check your answer. You don't have to show these calculations. You can check on your calculator as well, and then eliminate one of them if they are not true. In our second example, we have 1 minus 2, and the square root of 2x minus 1 equals to 12 minus x. Now before we start squaring on both sides, let's first get the square root alone. So we're going to isolate the square root. So I'll move the 1 over. So it'll become 12 minus 1. So that is 11 minus x. And on the left I have negative 2 square root of 2x minus 1. Now I can square both sides to eliminate the square root. So here you need to be careful. It is negative 2 squared, which becomes 4. Then in brackets, I have the square root squared, which becomes the contents of the square root. So it is 4 times 2x minus 1. Notice I'm using brackets because I need to multiply this negative 2 into the square root, or after squaring, multiply the 4 into 2x minus 1. And on the right, I have 11 minus x squared, which becomes 121 minus 22x plus x squared. If you don't know where the negative 22 comes from, remember it is 11 minus x times 11 minus x, and I multiply every term in the first bracket with every term in the second bracket. Now before I continue solving x, we need to multiply out. So 4 times 2x is 8x, 4 times negative 1, so it's negative 4. And that is equals to 121 minus 22x plus x squared. And now I'm going to transpose and rewrite in descending order. So it will be x squared minus 22x, and then I transpose the 8x, that becomes minus 8x. And then I move the negative 4 over the equal sign as well. So it is plus 121 plus 4. And now I can simplify further. So it's x squared minus 30x plus 125. Now sometimes people are scared to factorize. So no, you can use the quadratic formula. Or you can see it's simply 25 and 5, which will give me 30. And now I can solve x. So it's x is equals to 5, or x is equals to 25. And remember to check your answer. And as I said before, you can check on your calculator. So what I need to do, it's 1 minus 2 square root of 2 times 5 minus 1. So what you can do is you can punch that into your calculator and see the answer is negative 5. And then I check on the other side as well, 12 minus 5, which is equals to 7. But you can see negative 5 is not equal to 7, therefore x cannot be equal to 5. Let's check the other side. That's 1 minus 2 square root of 2 times 25 minus 1. You can also check on your calculator. So I punch it in my calculator and I see that is equals to negative 13. And then I test the other side as well. 12 minus 25, that is also equal to negative 13. So x is equal to 25. Okay, here we have a similar example as our first one. So what we can do is square on both sides in order to eliminate the square root. So on the left I have 5 minus x, and on the right 1 plus 2x plus x squared. Then I can rewrite this in standard form. So it is x squared, then 2x plus x, that's where the 3x comes from, and then 1 minus 5, that becomes negative 4. Now I can factorize. So it's x and 4, x and 1, and it needs to be positive, so it's plus 4 minus 1. So it needs to be positive 3x, that's why I make the 4 positive. And remember to check, so 4 times x is 4x minus x, that gives me 3x, which is the middle term. Now I have two possible values for x is equals to negative 4, or x is equals to 1, and I can check again, and you can use your calculator. So it is the square root of 5 minus 4, so it's the square root of 9, which is equals to 3. And on the right hand side, I have 1 minus 4, and that is equals to negative 3. And these two values are not equal to each other, so therefore x cannot be equal to negative 4. And for x equals to 1, it is the square root of 5 minus 1, which is the square root of 4, which becomes 2. And then 1 plus 1, which is also equal to 2. Therefore, x is equal to 1. And in our last example, we have the square root of the square root of x minus 1 equals to 2. Now we take the similar root as before. We can square on both sides in order to eliminate a square root. So I'm left with square root of x minus 1 is equal to 4. Then before squaring on both sides again, I transpose the 1, so I move it over the equal sign, so that becomes 5. And then I square both sides again. So it is x is equal to 25. Now let's check whether or not this is equal to 2. If I substitute x with 25, that becomes the square root of the square root of 25 minus 1, which is the same as saying the square root of 5 minus 1, which is the square root of 4, and that is equal to 2. So therefore, x is equal to 25.